David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. Today's lesson covers quadratic inequalities. And I wanted to start by just reviewing a basic inequality just to set the groundwork for when we talk about quadratic inequalities. So here is an inequality for a linear equation. So instead of y equals 2x plus 2, it's y is greater than 2x plus 2. So that just means that for all the values of x, y has to be bigger than twice x plus 2. Now we can graph these. So let's take a look and graph our linear equation here. Our y-intercept is 2, and we have a slope of 2. So that's up 2 over 1. So here is our graph. Now that's the graph of y equals 2x plus 2. The graph of y is greater than 2x plus 2 is a shaded region that's above this graph. So that's how we graph that linear inequality. All right, let's do this with a quadratic function. And we're going to do this algebraically, and then we'll also take a look at it graphically. So check this out. Here's our function. X squared minus 6x plus 8 is less than 0. So we're trying to find all the values of x for which this is true. So what we're going to do is we're going to solve this as though we're equal to x. We're going to find those two values, and then we're going to use them to analyze our results and find out what range of x makes this function less than 0. So let's do that. Now this one's an easy factoring problem. We have two numbers that multiply to positive 8 that add to negative 6, and those numbers are x minus 4 times x minus 2. And I'm going to set that equal to 0. Now what are my solutions here? This one gives me x equals 4, and this one gives me x equals 2. So now we need to analyze this result so that we can figure out what range of x satisfies my inequality. All right, the trick here is to plot these values on a number line. So remember, a number line is just an x-axis, and I have my values of 2 and 4. So let's put my 0 there, there's my 2, and there's my 4. Okay? Now, what we want to do is we want to figure out where's the function negative and where's the function positive. So less than 2, let's just try 1. What does 1 go in the function? 1 minus 4 is negative 3, times 1 minus 2 is negative 1. Negative times a negative, this is going to be positive. So it's positive that way. How about in between these two values? Let's try 3. 3 minus 4 is negative 1, but 3 minus 2 is going to be positive 1. So this is going to be a positive times a negative. So this is the function is going to be negative there. And if you do the same analysis, when it's greater than 4, the function is positive. Now, if you find it easier, you can plug your value of x into here to evaluate where it's positive and where it's negative. So now that we know that the function is positive this way, negative in between 2 and 4, and positive greater than 4, we can answer the question, when is the function less than 0? That's when the function is negative. So this is the zone, I'll put a little check mark there, for when the function satisfies our inequality. So now we can just write this range as 2, 4. Okay, so that tells us that between 2 and 4, not inclusive, so greater than 2 but less than 4, we could write this in set builder notation as the set of all x such that 2 is less than x, which is itself less than 4. And if you wanted to do that, you could do x element of real numbers. That would be a super thorough answer to this question. This one is just fine. Okay, now let's take a look at this graphically. For visual thinkers, this is maybe an easier way to understand this problem. So let's check this out. Now I'm going to draw my coordinate plane. I've got my two intercepts. There's 5. My intercepts are at 2 and at 4. And I don't need to be terribly precise to answer this question. This parabola opens up. I have a positive value for my quadratic term, so I can just sketch this in like that. Yeah, not super accurate, but good enough to answer my question, which is, when is the function less than 0? When is it negative? Well, here we are. It's going to be negative between 2 and 4. Remember, the function results in the y value, so we're looking at when is y positive and when is y negative. We want the function to be less than 0. It's this zone right in there. And so again, we could get this same answer, 2, 4, like that. So I've gone ahead and written one up here. What I'd like you to do is, first step, pause the video and rearrange that so one side is 0. So here's what I get. 2x squared minus x minus 2 greater than or equal to 0. I just subtracted x and added 3 to both sides. It does not change the direction of the inequality sign. Now remember, the one place that gets tricky is if you multiply the equation or divide it by a negative number, that would switch the direction of the inequality sign. Otherwise, you can treat the inequality sign just like an equal sign. Okay, so now that you have this equation, I want you to find the solutions. Now you might need to evaluate that and figure out what your best choice is going to be to find the solutions to that equation. All right, here's what I get. There's my plug-in step. And then I reduce that all the way down to just 1 plus or minus root 17 over 2. Now, if you didn't get that result, check your plug-in step, make sure you did that right, and then when you're satisfied, come back. So now I want you to make that number line we did in the last example using our solutions there. Okay, that's actually a little easier than it might have thought at first. You don't need to find out what the decimals are for these two answers. All you need to do is realize that the 1 minus root 17 over 2 is smaller than the 1 plus root 17 over 2, which would be bigger. So there's my number line. Now I want you to figure out which parts are positive and which parts are negative. Go ahead and mark those on your number line. Okay, here's what I got. I got positive here, negative in the middle, and positive there. There's kind of two ways to do that. The first one is kind of more straightforward, a little bit more qualitative, and that's to realize that this function opens upward. This parabola has a positive number on the squared, so that means it opens up. So that means the parabola is going to go like that. So it has to be negative here between the two intercepts and positive on the outside of the two intercepts. So that's a quick and easy way to figure that. The second way, which is a little bit more complicated, is to figure out a value of x that's living out here. And I can see that if I look at that, this is about negative 3/4. So I could take negative 1, which is further out there, plug it into my function and take a look at the result, and you'd see that that would be a positive number. You could do the same with just pick a value that you know is further over there, put it in the function, make sure the result is positive. Okay, so now I've marked my number line. Now I want you to list the solutions that satisfy, the x's that satisfy that quadratic function or inequality. That was a little bit more complicated than you first thought, right? Because we have two chunks, two ranges for x that work. We have the range of x that's out here, and we have the range of x that's over here. So my expression for the solution looks like this. It's the first range is from negative infinity to 1 minus root 17 over 2 inclusive. The u stands for union, so it's like an and. So it's this range and this range, which is 1 plus root 17 over 2 all the way to positive infinity. So this solution is a little bit complicated to state, but there you have it. All right, those last two examples were done algebraically with reference to the graph. Of course, it always helps to understand what your parabola is doing. It helps you interpret your algebra. But this time we're going to get a different prompt. We're going to get find solutions graphically. Now there's going to be two ways to do this. I'm going to do it, I think, the more simple way, the first way, and then we'll show you the second way after this board. So here's our function. So the first step is to rearrange it so 0 is on the right-hand side. Pause the video, do that. Now since the prompt is graphically, we can assume, at least at this point, that this problem would be on a calculator allowed version of a test. So instead of solving this with the quadratic equation and all that stuff, I would get out my GDC and put this in there and take a look at the graph. So go ahead and do that, copy the graph down on your notes, and then come back to this screen. All right, here's what I get when I put it into the GDC. Now check this out. I did label my y-intercept because I get this for free right out of the function. Just shows up right there. We're in standard or general form. Now, I want you to think about this graph and the question that we're getting, and I want you to figure out what the solutions are. What are the values that make this function greater than or equal to 0? And I want you to express that solution in the answer in the form that we've been using so far in this lesson. All right, let's check out one of the intermediate steps to answering that last question. First off, we need to figure out what the intercepts are. So I've showed you those to 3 sig figs. This one's 0.719, comma 0 right there. This one's 2.78, comma 0. So there's the intercept. So if you couldn't get that far, now you've got that. Make sure you can do that on your graphing display calculator. So now, pause the video and state the solution to this inequality. We're going to put that right over there. Okay, let's see how you did. This is very much like the last one. We want our function to be positive or equal to 0. So that's everything this side and everything that side of our two intercepts. Between the intercepts, the function is less than 0 or negative. So we have our first range from negative infinity to that intercept, and that's combined with our second range, which is that number to positive infinity. So there you have the answer to that one. Let's do a slightly different graphical approach. So check this one out. Here, we're going to treat these as two separate functions. So instead of bringing these values over and having one quadratic, what we're going to have is a quadratic function intersecting with a linear function. So what I want you to do, pause the video, get out your graphing display calculator, and I want you to graph this function, y equals 3x squared minus 7x, as one function, and then graph this second function, 2x minus 2. And take a look at your graph, copy it down, bring it into your notes, and see if you can figure out what your solution to this inequality would be based on the graph of these two separate functions. So here's my graph, copied over from my GDC. Now check this out, I have my linear function here, that's this one, and I have my quadratic function here, that's the parabola graph. So I'm just stopping in the middle here to give you a chance to check your graph and make sure you got that right. So check that out, fix that if you need to, and then I want you now to figure out what are the solutions to this function where the quadratic function is less than or just plain old less than the linear function. So go ahead and figure that out. So if you figured that this has something to do with the points of intersection of these two graphs, you're correct. So what I went ahead and did is use my GDC to figure out what those 2 points are. I listed them here. This one is that one, and then this intersection point is listed there. So if you haven't already done so, now what I want you to do is list the solution to this quadratic inequality. So what we get is we want this to be less than this one. So it's everything that's where the graph of the parabola is below the graph of the line. And so that's between these 2 points. So I listed the range of solutions that work. The values of x that make this true are starting with this one and going all the way to that one. And it's not inclusive. So it has to be a little bigger than that and a little smaller than that, hence my curved brackets. Here is a tricky IB type problem that pulls together a little bit of critical thinking and your understanding of inequalities. So let's take a look at the question. Find the values of k for which the graph of x squared plus kx plus 9 has no x-intercepts. So interesting. So we don't know what k is, but we need to find the values of k for which there are no x-intercepts. So think about what that means for a minute. Pause the video and figure out what it is that they're asking for about the parabola. There's a certain condition that the parabola has to fit for us to have no x-intercepts. All right, here's what I get from that. If there are no x-intercepts, the graph has to be above the x-axis, like that. We have a positive value on our x squared term. It's positive 1. And so that means the parabola doesn't open downward. Otherwise, it would have to be entirely below. So this is the condition that we're looking for. We're looking for the values of k that make this function create a graph that's above the x-axis. Okay, so now that we understand that, now we need to think about how do we find values of k that ensure that our graph is all above the x-axis. So think about that for a minute, come back. All right, now I'm going to pose a question. What does the discriminant have to be in order for this to be true? In order for the graph to be above the x-axis? Think about the discriminant. What condition does it have to have? For us to have no x-intercepts, the discriminant must be negative. That's a quadratic that has no real solutions, which happens when you get a negative discriminant. So all we need to do now is find the values of the discriminant that make it negative, and that will give us the values of k for which this graph has no x-intercepts. So take that understanding and see if you can do a next step. If you thought to set the discriminative to less than 0 and solve for k, you're right. So here's my discriminant set less than 0. I plugged in my values that I can. I don't know what my b is. That's my k. So I have k squared minus 4 times my a times my c. So that ends up being k squared minus 36. I set it equal to 0 so I can solve. I have k squared equals 36. Now k is plus or minus 6. So now figure out what the range of k values make this true. There's a couple steps here that we've been doing on all of our last problems. All right, I made my number line. Again, I'm going to use the fact that my parabola opens upward. This is my function now that I'm making my number line from. So it's not this function. It's the function of the discriminant where we're solving for the k in the discriminant. So this function is k squared equals 36. K's values are plus or minus 6. This graph, k squared, opens upward. It's positive. So that means that in between the two intercepts for this graph, not the function, what we have are negative here because the graph is a parabola going like that. So this range is negative. These two ranges are positive, going out towards negative and positive infinity. So then pause the video and write the range for the values of x that make this function have no x-intercepts. This is what I get. It's negative 6 to 6 non-inclusive. So all the values between negative 6 and 6 make the discriminant negative. We've written the discriminant as a function. They make the discriminant negative, which in this function, when the discriminant is negative, there are no x-intercepts. So that answers that question. The math here, not very complicated, but I think the critical thinking to crack this question open can feel hard. Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.